Number one, what is a radian? That's what we need to know. Degrees versus radians. A radian is the ratio of the length of an arc. Now guys, an arc would be part of the outside circumference. Okay, it's part of the outside edge. So it's a ratio of the length of the arc and the length of the radius. In other words, guys, if we have a circle, and you don't have to draw this, we know the arc would be this chunk right here in red. How long is that versus how big is R? Get it? So a radian is that ratio. Now the big thing is we need to know how to convert between degrees and radians. You need to know right here that if a circle starts at 0 degrees, it then goes counterclockwise to 90, over to 180, down to 270, and back to what? 360 degrees. Now radians still start at 0, but now it's pi over 2, pi, 3 pi over 2, and then this is 2 pi. So what we know is the following. Guys, we know that 360 degrees is equivalent to what? 2 pi radians. Yeah. So we know that 360 degrees is equal to 2 pi radians. And radians don't really have units. Okay? So how do we switch from degrees to radians? We take degrees, whatever the degree is, which would be theta. That would be degrees, and we multiply it by what? 360 degrees over 2 pi. So if we have degrees, we put degrees in the top, we have to put degrees in the bottom, don't we? And do you notice this is the same? This is our equivalency, isn't it? So, for example, if I want to switch 90 degrees out, then I'm going to do 2 pi over 360. 90 goes into 360 how many times? How about 4? 9 goes into 36, right? 2 goes into 4 how many times? Twice. So 90 degrees is the same as pi over, and look at that. 90 degrees is the same as pi over 2. See them? So why don't you try one for me here? Why don't you try 30 degrees? Can you convert 30 degrees? How many radians would that be? Multiply it by the conversion factor just like I did. Multiply it. What's the conversion factor going to be from degrees to radians? It's right here, guys. Multiply it by 2 pi over 360 and reduce. Now, to be nice to you, if you just leave the pi off, you can put this in your calculator. I probably shouldn't even show this to you. So we know this was the same as pi over 6, right? So why don't you try one that's not so nice? Convert 86 degrees for me, please. Multiply by what? Put it in your calculator, and don't forget to put the pi back in when you do it. Take the pi out when you're in your calculator and then put it back in. Anybody having trouble figuring out how to put this in your calculator? (43pi/90). Anybody need any help? Okay. Look, we're going to take 86 and multiply it by 2pi over 360, right? So, put radians to degrees. So if I start with radians, what do I need to multiply by? If to go from degrees, I went 2pi over 360. To go to radians, from radians to degrees, I need to do what? 360. Thank you. 360 degrees over 2pi. We just flip the ratio over, don't we? All right, so the next question is always, well, how do I know if I'm in radians or degrees? Hello, degrees have a degree symbol. Radians don't. Or they have a pi. Okay? So let's look at one. Yeah. It has to be. If you're going one way, it's pi over 180. Then the other way, it would be 180 over pi. You have to go the opposite way. And if you don't like 360 equals 2pi, you can do pi over 180. Because if you divide 360 by 2, you get 180. So let's look at pi over 16. Pi over 16, we're going to do 360 over 2pi. Because guess what happens? Those go away. Now if I want to put it in my calculator and reduce it, all I have to do is put the top is 360 and the bottom I do 16 times 2. Now, nice thing is for these is you don't have to put it back in a fraction. You can leave it as a decimal because it's in degrees. You should get what, 11.25 degrees? Don't forget the 2. All right, so you guys try one. Try pi over 4. Yeah. On the calculator? Sure. All right. Here. Everybody got 45 degrees? Successful? Good. So let's take care of some housekeeping technology, or terminology. How do we measure angles on the coordinate plane? This piece of the angle right here is called the vertex, right? This is called the initial side, the side where we start measuring from. And this would be the terminal side, where we stop. And we measure from the initial side counterclockwise to the terminal side. So standard for the coordinate plane, for a positive angle, we go counterclockwise from the positive x-axis. So if we go counterclockwise for a positive angle from the positive x-axis, what do you suppose we do to find a negative angle? Clockwise from the x-axis, yes. Yes. Counterclockwise would be from the positive x-axis that away. Clockwise would be from the positive x-axis, we'd go this way. Like the hands of a clock would tick, right? Clock ticks, tick, 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 tick. Always starting at the positive x-axis. Everybody good? I'm waiting. Now what that means is since we can go in more than one direction, we can have more than one angle measure for the same ending place. When we have more than one measure for the same ending place, they are called co-terminal angles. Co meaning like cohabitate together, right? You live together if you cohabitate. Co meaning together. Angles that together have the same ending point. Now, how can that be? Type of angle? So if we're measuring the angles that have the same initial and terminal sides. But different measures. How? One of two ways. We can either rotate the other direction, in other words, we can measure positive, or we can go the other way and measure negative. Or extra rotations. And I'll show you what we mean by that. So for rotating the other direction, I want you to think about it. If I have an angle, I'm going to put it here. I have two choices here. I can either go from the positive x-axis this way, right? And this is some angle theta. Or, guys, I could do the following. I could start here, and I could go the other direction and end up there. Those two angles, do you see that they start at the same place and they end at the same place, don't they? But one is obviously a different size than the other. So if this guy is theta, how do I find the one in blue? How many degrees is in a full circle? Ah, say it louder, Carlos.
360.
Yes. So this guy would have to be the 360 degrees minus whatever the red one was, whatever theta was, right? That would be one angle that could be coterminal. So that's the rotate the other direction one. Now, we've got another possibility. I said extra rotations is the other possibility. So here we go. We've got theta. However, instead I could go all the way around and then back there again. So how do I find this one? Every time I go another rotation, I go an additional what? 360, don't I? So this is going to be 360 plus theta, isn't it? As a matter of fact, I could go multiples of this. What if I went around 2 times and then went to the angle? That would be 2 times 360 plus theta, wouldn't it? So in reality, what I could do is I could do this multiple number of times. In other words, I could start with theta, 360, go n number of rotations, right? And is 1, it's 1 rotation, and is 2, it's 2 rotations, and 3, etc. And then plus theta. So I've got a general formula for finding them. Everybody good with that? Yes. Okay, so let's look at this. It says find the coterminal angles. Use the formulas in sketch. So if I want to find 2 coterminal angles, just 2, or all of them, we could do all of them. So how do I find one coterminal angle? The backwards one. If the angle is 42, how do I find the one that's backwards from it? 360 minus 42, which would be what? But I measured it the other direction, didn't I? If I measured it the other direction, what do I have to put in front of it to indicate that it's going the other direction? What did we say? It would be, guess what we have to put in front of this guy? We've got to put a negative in front of it. Now, are you going to forget that? Because if you're going to forget that, how could we make it show up every time? instead of doing 360 minus theta, what could we do? Oh, we could maybe make this better by saying, why don't we do theta minus 360, and that will make it happen automatically. You like that better?
Yes.
I figured you would. All right. Now, all the other ones are going to follow that formula, aren't they? So now, for all the rest of them, we need to do 360 times n plus what? 42. And that will give me all the rest of them. So now it said sketch too, didn't it? So let's sketch this. Oh, come on. It can't be that hard to do. Where is 42 degrees going to be? First quadrant, almost in the middle, right? So we just labeled this 42 degrees. And how do I indicate the other one? It's part A. Oh, it says draw. We could put that down here, couldn't we? I'm sorry. I forgot I put part B as draw. So what do I label that other piece right there that I drew in? Negative 318. All right, so now we can draw one coterminal angle to 42 degrees. So we need to do one of those that's 360n. So if I want to draw one of those, what's the first thing I plug in for n? How many rotations? 1. So we do 360 times 1 plus 42, which would be what? 402 degrees. So now we want to sketch that guy. We draw in 42 degrees again, don't we? And I'm just going to change colors so you can see it easily. You don't have to. So now we want to do what? Go this way and then go again, don't we? And that's the one in blue is the one we would measure and draw as 402. What would it have looked like if I'd done 2 of them? Go around once, keep going around again, and then a little bit. Okay. Then this today for this? No. All right, so what about for pi over 6? Now, most of you don't think in terms of radians, do you? So what's the easiest way to do with this? Pi over 6 becomes what? You got 2 choices here. You can either swap it out to degrees, or I'm going to make you work it as radians. Pi over 6. Where would pi over 6 be? First quadrant, wouldn't it? Well, okay, so here. 360 over 2 pi, right? Pi goes away. So 360 divided by 12 is 30 degrees. So it's 30 degrees, isn't it? First quadrant. So if you're never sure and you don't like dealing in radians, swap it to degrees. You could always swap it back if you needed to. Okay? It's an easy calculator thing, isn't it? All right, so now let's find 2 angles in terms of radians, because I want you to know how to do this in terms of radians. So, if I had to do this in terms of radians, and you don't have to sketch it, I'm just sketching it to help you. 30 degrees is about here. So this is pi over 6. So if I want to find one going the other direction, I want to find this guy, don't I? Normally I would... Huh? Yeah. Oh, it's here. Guys, normally we would subtract from 360 or take 360 and subtract from this, but we're in radians. So what is the radian equivalent of 360? 2 pi. So instead, we're going to take whatever this is, theta minus 2 pi, aren't we? So we're going to take 2 pi, or pi over 6, right? And subtract 2 pi from it. Now we need to get a what? Common denominator. Common denominator is 6. isn't it? So I need to multiply top and bottom by, so now I get pi over 6 minus 12 pi over, which is what? Negative 11 pi over 6. So there's 1. Now, to find a second one, instead of subtracting 2 pi, what are we going to do this time? Add 2 pi. So we're going to start with pi over 6, and we're going to add 2 pi. Now, you've already changed this once. 2 pi is equivalent to what? 12 pi over. Do you see why we had to get the common denominator? How do you change the common denominator to 6, isn't it? But guys, do you see you've already done it once? Why would you do it again? Just bring it over and make it plus 12 pi over 6 instead of minus 12 pi over 6. So this is going to become 12 pi over 6. So what is one of them now? Yeah, 13 pi over 6. Okay. Guys, this too you could do on your calculator if you just don't feel competent about doing it. You could do 1/6 plus 2, and it will spit out the fractional part next to the pi. And just tack the pi back on. You understand what I'm saying? I'm going to fill this thing out on its together, and I'm going to show you some tips and tricks. Guys, you can memorize it, but it's going to take you a while to figure out where everything is. Oops, hold on. All right. All right, so here we go. This is basically what yours looks like. So what you need to know is you need to fill in the degrees first. This is 0 degrees, isn't it? Yes. This is 30. This is 45. This is 60. This is 90. 120. 150. No. 120, excuse me. Let me think about this. 135, 150, 180. 180 plus 30 is 210, 225, 240, 270, 300, 315, 330, ends at 360 degrees. Now, you see the pattern? It goes 30, 15, 15, 30, 30, 15, 15, 30, 30 degrees, 15 degrees, 15 degrees, 30 degrees, 30 degrees, 15 degrees, 15 degrees, 30 degrees, and so on and so forth, all the way around. Okay? Now, let's deal with the radians next. This is 0 radians. Guys, this is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. No, pi is over here. Now, you need to just be able to find or know pi over 6, pi over 4, pi over 3, pi over 2. Notice that the number on the bottom is successively getting what? Smaller. 6, 4, 3, 2. You're just skipping the 5, right? 6, 4, 3, 2. Now, here's the cool thing. There's a pattern. Notice that this is pi over 3. You see it? What is 1 plus 3?
4.
Then straight down from that is 4 pi over 3. It works the same for all of them. 1 plus 3 is what? So straight over is 4 pi over 3. Now watch how it works. What is 1 pi over 4? What's 1 plus 4? Follow that spire straight over, and guess what? This is 5 pi over 4. I bet you can guess, since this is 1 pi over 6, what's 1 plus 6? Follow it straight across. This becomes... It also works for this one. What's 1 pi over 3, right? So what's 1 plus 2? So this becomes 3 pi over 2. Now, those are easy. So now you get the first and the third quadrant, don't you? Second quadrant and fourth quadrant are going to act the same way. So we just need to find the second quadrant, don't we? Second quadrant is 1 less than on the top than each of the denominators in the bottom. So what is the denominator here with 3? 3. What's 1 less than 3? 2. This becomes 2 pi over 3. It was 1 over 3. Now it's 2 over 3. Because 2 is 1 less than 3. So now if it's 1 over 4, what's 1 less than 4? So this becomes... Can you guess what the other one in the second quadrant is going to be? 5 pi over 6. No, actually, there's one formula for this that you just need to memorize. You can get these from those by going 1 less than the denominator, and then guess what? To get the fourth quadrant, all we have to do is the same trick we did to get the third quadrant. Add the top and the bottom, and that gives you your new top. So what is 2 plus 3? So this would be 5 pi over 3. Can you guess what the one on the 315 is going to be? And what's the one on 330 degrees going to be? This is, how did I get 11?
No, like that quadrant.
Add top, bottom. Like, what's 3 plus 4? 7. Same denominator. All right, so now this is like 1 over 1, isn't it? What's 1 plus 1? Oh, so this is 2 pi over 1, which is just what? 2 pi? All the way around. That's how you get these. That's how you get those values. Okay? Now, how we get the sine and cosine values is different. Let's look at the sine and cosine values. Here's the cool thing. Every one of these angles produces a right triangle that is a special right triangle, doesn't it? 30, 60, 90, or 45, 45, 90. All right? We know the radius. If we go around the circle here, and we form an actual circle, we know the radius of this circle. The radius right here is 1 unit, isn't it? So the value at this point, the x coordinate here is 1, and the y coordinate is 0. Do you agree? So go to the other side over here. What is the coordinate going to be, the xy coordinate going to be at that point?
0, 1.
No. It's still on the x-axis. Negative 1, 0. Now, what about up at the top up here? If this is a circle, 0, 1. And what about at the bottom down here at 270? Negative 1. These are called the quadrantiles because they are dividing the quadrants. Okay? Now, for every one of the rest of these, you have to know there are 3 values for all the rest of these that you will use. Now let me remind you. The 3 values are as follows. 1/2 square root of 2 over 2, square root of 3 over 2. This is from smallest to largest. Those are the 3 values that end up on these as these. Now, this is the one I refer to as short. This is the one that I refer to as long. This is the one I refer to as same, and you'll understand why, because the 2 and the 2 up and down are the same, aren't they? Do you understand why I call them short and long? Look at the top number. All of them are over 2, aren't they? The smallest number is 1, isn't it? And 1 and 2 aren't the same. I call it same because the 2 and the 2 are the same, aren't they? And then root 3 is the biggest, so it's the longest, okay? Now this is how I memorize it, because I can picture it in my head. All of the ones that are pi over 6. Pi over 6, pi over 6, pi over 6, pi over 6. Do you notice they're all closest to what axis? This one, isn't it? If we were to make a right triangle right here, do you notice that right triangle has a long side and a... Ooh. And guess what the long side value is? Guess what the short side value is? Short. So the x-coordinate here is root 3 over 2, and the y-coordinate is 1/2. Now, that's the same for every single one of these. The only thing that changes is the sign on the x and the y based on which quadrant it's in. Did you follow that? Let's do one of them just in color, and then I'll do it. So do you see that this is a right triangle right here? There's a right triangle. This is the long side, isn't it? Well, long side is root 3 over 2. Short side right here is 1/2. So the x-coordinate is root 3 over 2, and the y-coordinate is 1/2. X being side to side, y being long. Now, guess what? Every one of these is the exact same. Root 3 over 2, 1/2. Root 3 over 2, 1/2. You know the only thing I'm going to have to change is the sign. So in the second quadrant, x is what? Negative, and y is positive. In the third quadrant, x is negative and in the fourth quadrant, x is positive and y is, but the root 3 over 2 and 1/2 didn't change. You will hear me say, as I'm asking you, what are the values? This is how you don't have to memorize it and draw it. I'm going to ask you to picture it on the, picture where it's at. All pi over 6 values are closest to the x-axis, aren't they? If all of them are closest to the x-axis, that makes all pi over 6 long, short. Now let's look at the pi over 4s. All the pi over 4s are exactly in the middle, aren't they? Which one of those values is in the middle?
Same.
And think about it. These are all 45, 45, 90 triangles, aren't they? So what do you know about the 2 legs in a 45, 45 triangle? They're both the...
Same.
So guess what the x and y coordinate is for every one of these? Root 2 over 2, root 2 over 2. Do you see it? It's the easiest way I know how to help you memorize. Root 2 over 2, root 2 over 2. Now guess what? Every single pi over 4 is the same, only you're going to change the signs. So this is root 2 over 2. This is root 2 over 2, root 2 over 2, but it's going to be negative in the x. This is root 2 over 2, root 2 over 2, but it's going to be negative for both. This is root 2 over 2, root 2 over 2, but it's going to be negative for the y. Does anybody not see it? Please tell me if you don't see it. So negative root 2 over 2, root 2 over 2, negative root 2 over 2, negative root 2 over 2, root 2 over 2, negative root 2 over 2. And I bet you could see what's coming with the 60s. With the 60 degrees of the pi over 3s, all the pi over 3s are closest to the y-axis, aren't they? Here and here. So if I make a triangle, look what I now have. Instead of long, short, all of these are short, long. Which means every one of these is 1/2. Yeah, root 3 over 2. If you'll just remember, long, short, same, short, long, you can get them. So this is going to be 1/2 root 3 over 2, negative 1/2 root 3 over 2, negative 1/2, negative root 3 over 2, and then finally 1/2 negative root 3 over 2. What we will practice over the next little while, if you remember this, it makes it really easy to sketch it if you have to sketch it real fast on your test. If you're a sketcher and you know these tricks, you can, 1 minute, you can have it on your paper. That's a worthwhile sacrifice, isn't it? And you don't have to worry about memorizing it per se. What you need to memorize, if you memorize anything, is this first quadrant, don't you? And then how to get those radians. And then everything else will come out. Okay? All right. So how are we going to use this? Is it really almost time? Ooh, okay. That's all right. We may have to finish this some other time. Let's see. We found quadrantiles. We did that. We did all the rest of the angles. So we did that. We covered all. What about tangent, cotangent, secant, and cosecant?
Where's that?
It's on the last page. What about tangent, cotangent, secant, and cosecant? Here's the thing. If you know tangent is this. Sine over cosine. And you're going to know the sine and the cosine values, aren't you? Cosecant is 1 over sine. So if you know the sine values, you just flip them over. Secant is 1 over cosine. And cotangent is just cosine over sine. So all you have to know to find any of them is you have to know, get off your phone, bell hasn't rung yet. All you have to know is sine and cosine on the unit circle. The rest of them fall out. Now, what if the angle is more than 2 pi? Then you need to subtract out the 2 pi enough times until you get something that is below 2 pi. In other words, if I had 11 pi over 2, I would need to subtract 2 pi from it. So I would do 11 over 2 on my calculator and minus 2, minus 2, minus 2, until I got something that was less than 2 pi. And then I could look on my unit circle and figure out what it was. Does that make sense to everybody? Now, how do we find something like that? Easiest way to do that is, let's look at a couple of them. So if I wanted you to find the cosine of 5 pi over 6, that one's easy. You just look on your unit circle. What is the cosine of pi over 6? Does everybody understand that cosine is your x value? And sine is your y value on your unit circle? So what is the cosine of 5 pi over 6? I can tell you real quick. 5 pi over 6 is less than pi, so that is the second quadrant. It is close here, so it is long. It is negative root 3 over 2. You see how I just found it in my head? I don't need my unit circle. I just do the pi over 6 to tell where it's at, located. Pi over 6s are all next to the x-axis, aren't they? So this is here, so it's a long short. Cosine is the long, root 3 over 2. Second quadrant, so it's negative. Okay? Yeah, y'all can go. All right, don't forget to write down your homework. Only odds. And it's not all odds either. It's 1 through 25 odd on the first page and 1 through 65 odd on the second. Use your unit circle to help you find values. Okay? We will practice this more. Well, it says 4-1, 4-2, and 4-3 homework.
I think I'm throwing.
Yeah. 4-2 homework is right here. 10 through whatever, here. 10 through 25 right here. The rest of it's 4-3. So do the 10 through 25, do the, or 11 through 25 odd right here. Odds, and then do the odds here. Just do all the odds. Do all the odds. Just do all the odds. Bye, guys. See ya. And we are going to practice this for a whole nother day. Next time I see you, we are going to do nothing but practice finding values on the unit circle, no matter what they are. Okay?
Miss Duffy,
Give me.
to lead, can we use these stairs?
You cannot use those stairs.
Oh, what happened?
You're just not allowed to.
What was
Well, things like your raunchy classmates at some point or another probably tried to have relations in that stairwell. And so-
Relation.
That is raunchy.
Oh yeah.
That is nasty.
Or fight in that hallway, or smoke or take drugs in that stairwell. So because it's out there, so
Actually,
nobody's allowed to
you
see
know,
it.
I have seen people make out in the.
It's weird.
Someone made out during a fire drill one time in Stubby. I was traumatized.
You remember that?
I turned around and I saw two people making out, and I'm like,
That's so
What's
gross.
that smell?
If your life is on the line,
we finna get into. Oh, not a fire drill. I meant a tornado drill. Wait, no.
I wrote in my pants on it.
Did you go outside or just go downstairs? A lockdown.
With the lights off.
Ew.
He's not great. You're not seeing this right now.
Look, I know y'all are all like raging,
feel the air on
all
your
one
head?
raging hormone, but
But not at school, please.
not at school.
I'm saying. And midday. It was like 8 in the morning. What are you doing?
Right, y'all just woke up. Right, take a breather. Don't call your parents
Okay, that's
on
none of y'all.
Right.
Anybody in here in cheer? Okay, that's none of y'all.
David, he is. I'll tell you what.
If it's a Wednesday,
No.
Thursday, absolutely.
No, like, you understand.
Okay. Oh, my phone, I forgot.
Yeah,
Oh, yeah.
They go like, do it more. Why not? Just do it.
I'm about to jump to be a mouth. What's the category today?
We need to do music again, y'all.
So,
No, they were so mad yesterday. Like, no,
What if we
music.
do random?
We did movies yesterday. Today, let's do.
Oh, I missed it.
famous.
It was really fun. It was. I'm sorry to admit it, but it was really fun.
We always have random.
Let's do.
Famous.
Or like
Ow.
actors.
Actors.
Do
Yeah.
like famous actors. Or like,
Okay, just
or like
do
celebrities.
Just celebrities.
Yeah, let's do celebrities.
The emo kind of celebrity.
Who?
Emo.
Just famous people.
Fish.
He's like, I don't know.
Oh.
I thought you were saying emo, not emo. I was like, emo?
Emo.
Famous. Emo.
Just do TV shows.
No, let's just do. No, let's just.
Okay, let's do celebrities. I'll go first. Okay.
Wait, I'm gonna not. I'm not gonna do this. Oh, she already do. I wanna do a funny one.
A. E.
my fun anyhow.
Oh, I bet.
They have a
We are
good-
blast.
They have a good time. You guys do. I like it.
Dave.
Oh, that's it. Zendaya.